Let's take a look at a couple more examples of making tree diagrams and using the fundamental counting principle, and then how we can connect it to actually finding some probabilities. So in this example, you're going to be at a conference and you have the option of 3 drinks, Coke, water, or juice. There's going to be 2 sandwiches, ham or turkey, and 2 chip choices, Doritos and Cheetos. So the first question is, how many possible lunches are there? So we're going to assume that you can't omit from any of these 3 categories. So you have to choose in your lunch a drink. Okay, so I'm going to put down a blank to represent it, and I'll just label underneath. So you have to choose a drink, you have to choose a sandwich, and you have to choose a chip. So for each one of these options, let's record how many choices you have. So for drinks, you have 3 choices. Sandwich, you have 2 choices, and then chips, you have 2 choices. So how many possible lunches are there altogether? We're going to multiply these out, so we get 12 possible lunches. So let's organize them into a tree diagram and then list the sample space. So again, we're going to have 3 stages. So the first stage will be our drink choices. So I'm going to use some abbreviations here. I'll use C for Coke, W for water, J for juice, H for ham, T for turkey, and then D for Doritos, and then for Cheetos, since I already have a C, I'll just use maybe CH. Alright, so for drink choices, you can either have a Coke, water, or juice. Alright, so there's 3 options at that stage. Now once you choose a drink, let's go to the sandwich choices. You can either have ham or turkey. So from each one of these, I'm going to branch off 2 and then put ham and turkey at the end of those branches. And then finally, let's choose our chip. So for our chips, for each one of these, I'm going to branch off 2 times again, and I'll put either Doritos or Cheetos. So we're going to have to start squishing this in here. Doritos and Cheetos. The worst that you would ever probably be drawing a tree out, at least in this course, would probably have 16 branches total. So it's helpful to know how many options there are before you begin. So just kind of way you can organize your spacing. Alright, so there's the tree diagram for this lunch choice. So let's go ahead and list the sample space. So we're going to start here at the beginning and go all the way out to the end of a branch. So you would have C, H, and D. That stands for a Coke, and then a ham sandwich, and then Doritos. C, H, and then CH. That would be a Coke, ham sandwich, and Cheetos. C, T, D. That stands for Coke, turkey, Doritos. And then you could have Coke, and then turkey, and then Cheetos. Alright, coming down to the water choices. So these are going to look very similar, except instead of having a C in the front spot, I'm going to have a W. So I'll have W, H, D, water, ham, Doritos, water, ham, Cheetos, water, turkey, Doritos, and water, turkey, Cheetos. So then that accounts for this middle branching. So then finally we'll come down here, and then we're just going to have juice as the front choice, and then we'll finish this off. Alright, so there are the 12 choices that would be in the sample space. So now let's use this information to answer some questions. If a customer randomly selects one of the lunch specials, determine the probability that the lunch with ham is selected. So the probability that the lunch has ham. So we don't care about the beverage choice, we don't care about the chip choice, we just care that the lunch had ham. There are 12 options in the sample space, and then how many of them have ham? So then it'd be 1, 2, 3, 4, 5, 6. So 6 out of 12, or half of the possible lunches have ham. Next question, if a customer randomly selects one of the lunch specials, determine the probability that neither juice nor Cheetos is selected. So we want to find the probability of not selecting juice nor Cheetos. So there's still only 12 options in our sample space, so let's go through and pull the ones that either don't include juice and they can't include Cheetos either. So neither of those is okay. Alright, so all of these last ones would be out because they all have juice, right? So these all would be thrown out. And then we're going to throw out any of them that have Cheetos. So that would be this guy, this guy, this guy, and that guy. So how many of them then don't have juice and don't have Cheetos? There'd be 1, 2, 3, 4 out of the 12, or 1/3. So having the tree diagram is really handy to visualize all the different outcomes to help you list them, to be able to answer questions about probability. So let's take a look at using the fundamental counting principle and answering some other questions about counting. Now these ones aren't necessarily going to require us to draw a tree, but you're more than welcome to if it helps you visualize it. So in this next example, it says a website requires a 4-digit PIN. How many pins are possible if the numbers are selected with replacement? So it has to be a 4-digit PIN, so I'm going to put down 4 blanks for each of the possible digits. Okay, so in each of the spots you can have the number 0 through 9. So if you can have 0 through 9 in this spot, there are 10 options here. And with replacement means that whatever number you pick for the first spot, if you wanted to, you could pick that same number again for the second spot. So that means you still have 10 options for that second spot. Then you would have 10 options for that 3rd digit in your PIN, and then 10 options for that 4th digit. So then we're going to multiply all of those together. The shortcut for this calculation would be 10 to the 4th power, or 10,000 possible pins. Okay, so we're seeing here that you wouldn't want to begin drawing a tree diagram for this. Right, so your tree diagram, when you're done, it would have 10,000 end branches. So that starts getting a little crazy. So on these ones, we want to start being able to determine how many stages there are to the experiment, and then what are the possibilities on each stage. Now, this same problem, you're going to pull a 4-digit PIN, but this one's going to be without replacement, which means once you pick a number for a spot, you can't choose that number again, ever. So you have the digits 0 through 9 that could be in the first spot, but then once a number is picked for that spot, for your second spot, you only have 9 digits left. So for instance, let's say in the first spot, let's say you chose, like for instance, the number 7. That means in this spot right here, you could have 0, 1, 2, 3, 4, 5, 6, 8, or 9. You wouldn't be able to pick a 7 because you already chose it for the first spot. So on the first spot, you're totally open in all 10 digits, but then your count gets reduced based upon the choice made previously. You're only going to have 9 digits left. So then there would be 8 for the next spot and 7 for that last spot. So you multiply those together using our counting principle, so there's going to be 5,040 possible pins if your pin has to have all the digits without replacement. And in this next one, we're going to use the counting principle, but this one we're going to have to be a little bit more careful with some of our counts. So it says at the JJC Chef's Table Kiosk, there are 3 different sandwich and wraps, 2 salads, 2 soup choices, 3 sides, 3 choices for baked goods, and 2 options for ice cream. Now for their combo meal that's for $6, you choose 1 entree, which means you can either choose a sandwich or a salad, 1 side, 1 soup, and 1 dessert, either a baked good or ice cream. And the question is, how many possible lunch meals are possible? So in this one, let's keep track of what a lunch meal is. So for this lunch meal, this combo, you can choose an entree. So I'll put down a blank for that and label that. So it's an entree choice. You can choose a side. You get some soup. And you get a dessert. So let's go and figure out the count for each one of these different stages of this choosing this combo. Now for the entree, you can choose either a sandwich or a salad. So you don't get both. You have to pick either a sandwich or a salad. So there are 3 sandwich options and 2 salad options. So overall in this entree choice, there are 5 options. So 3 sandwich plus 2 salads. So in this one, we're going to add those just to see how many options are sitting for that particular stage. So let's go to our sides. So we have 3 sides. That's pretty straightforward. There's only 3 side choices. For soup, what do we have going on for soup? For soup, we have 2 choices. And then finally for dessert. Now our dessert, you can either choose a baked good or ice cream. So we have, looks like 3 choices for baked goods and then 2 choices for ice cream. So overall in our dessert choices, you're going to have 5 dessert choices. 3 for the baked goods and then 2 for the ice cream. So then we want to multiply 5 times 3 times 2 times 5. That would give us 150 possible combos for their lunch options. So for this one, you just have to be careful to not just pull all of these numbers blindly and multiply them. You kind of have to see what's going on for your individual stages and then see how many options fit that stage.